Hello viewers, in this virtual class we're going to look at the derivative of this function by using apply logarithm, differentiation, to establish this fact. You say y is equal to uv over w, show that the y ds is equal to uv over w, open bracket 1 over u times the u dx plus 1 over v times the v ds minus 1 over w times w ds close bracket. They say hence find the derivative of y is equal to open bracket 5x squared minus 3 close bracket cos s all over exponential raised to power for x. Okay, first and foremost we want to establish this using logarithmic differentiation. Okay, now we have y is equal to u v all over w. Yes, for applying logarithmic equation here, we also know that we need to understand the laws. So we say ln is in y is equal to, for applying it to this side, this become ln u, because this is product become addition, and ln v, this is division become subtraction, this become ln w. And we know that if we are finding derivative of a logarithmic equation or function, it simply means that it's going to be 1 over y, the y over the x here, because we are differentiating with respect to x. So similarly for this, if we are differentiating the u, it's going to be 1 over u, the u, the x. Similarly, ln v is going to be 1 over v times the v over the x. Then ln w is going to be 1 over w times the w over the x. So that is the derivative of the logarithm. So in our previous video, we've established that how to derive the exponential function, the derivative of exponential function. So from here we can see that our dy over dx becomes this y where we multiply both sides by y. So this y will be off, and here we have a y open bracket. This is 1 over u times the u over the x plus 1 over v times the v over the x minus 1 over w, the w, the x. So we close that bracket. But if you recall that your y is an expression, and the expression is equal to uv over w. So that if we do that, our dy dx become uv over w, and open bracket 1 over u times the u the x plus 1 over v times the v over the x minus 1 over w times the w the x. So we'll be able to establish this first fact, and you can see that we are not given a question to resolve here, that if we have a function y is equal to 5 open bracket 5x squared minus 3x cos x over exponential raised to power 4x. Okay, here what do? We apply the same techniques here. So we take ln of both sides. We say ln y. So if I apply the ln here, this become ln open bracket 5x squared minus 3 plus ln cos x minus ln exponential 4x. So immediately you are applying ln here. It's like we are saying ln e raised to power 4. Once you apply ln here, everything here will become just 4x. That is the meaning. So from the same base. Then next we can write this ln of y is equal to ln open bracket 5s squared minus 3 plus ln cos x minus 4x. Okay, so here let's now find the derivative of this. This will become 1 over y, the y, the x. So if I differentiate this, we differentiate the inside now. When we differentiate this side, this becomes 10x all over our u. Our u here is the quantity inside here, so it becomes 5s squared minus 3 plus, if we find the derivative of cos x, it's going to give us minus sine x, then everything over the u there is cos x here. So here if we find the derivative of this, we just give us minus 4. Okay, minus 4. So here we will see continue here 1 over y of x, the y, the x is equals to, we close our bracket first. Here we look at this, this is 10x all over 5s squared minus 3. Here sine over cos, that we can also transform it to be what? Tan x, and this becomes tan x minus 4, we close our bracket. Recall that we're going to multiply both sides by y, so that our dy ds becomes y into our 10x all over 5s squared minus 3 minus tan x minus 4, we close our brackets. But you recall that this y has an expression, so we can easily transform it, that our dy dx, seeing that y has an expression which is 5s squared minus 3 cos x over exponential 4x. I'll close our bracket, and the quantity in this here will be 10x all over 5s squared minus 3 minus tan x minus 4. Okay, this is the derivative of this expression. Okay, here this is very important. The derivative using logarithm, to differentiate is very important. Once you do it, you can handle every other rules that is applicable. So all you need to help me do, please help me subscribe. Subscribe and also share this with all your social media platform. Have a nice time. See you in my next virtual class.